Hello and welcome to this video on clustering algorithms. Today I'll be your teacher, Jazamrit Rahala, or Jam. This is part of a video series on machine learning led by myself and my good friend Asman. So let's see what we'll be covering in today's video. We'll be talking about why you'd use clustering algorithms, when they're used, what they actually are, and we'll be covering three main types of clustering today, each increasing in complexity. We'll talk about hierarchical clustering, which deals with pairwise elements. It's often used in genetics and science fields. Then we'll move on to k-means clustering, which is a slightly more refined version of hierarchical. It's often used in economics or when looking at consumer data. And then finally, we'll be looking at Gaussian mixture modeling or mixture clustering, essentially like k-means, but again, slightly more refined and a bit more complicated. Okay. So what are clustering algorithms? Clustering algorithms help us split up data into k unique groups without labels. Therefore, it's classified as unsupervised learning because the data doesn't have any labels. There are two main types of clustering. There's hard clustering and soft clustering. Hopefully you can get a rough idea of what does what. Hard clustering has hard boundaries, meaning that anything within a certain range of the center of the cluster is classified as 100% blue group or red group. Whereas with soft clustering, there's a gradual transition between different groups. For example, here we have definite reds and definite blues, but within the boundary, we're getting some kind of purpley grayish colors. This is soft clustering. So what are the actual applications of these clustering algorithms? Well, there are three main applications that I could think of. There's pre-processing data for supervised learning. In our example, we have a data set on flowers, including petal length, width, petals, stem length. There's a lot of data here. However, the more data we have in our models, and the longer it takes for the models to churn up answers. Therefore, what we could do is we could start grouping them into clusters and say this cluster, or this group of flowers is known as group 1, group 2, group 3. By summarizing all this data into one refined value, we can help speed up the training process for different models. Another key aspect of applications for clustering algorithms is pattern detection. This is often used within the science field or the economics fields. So let's say we have a group of different patients who are trialing out a different type of, who are doing some exercise. In this example, we have the red group, the purple group, and the blue group. And let's say within the blue group, we've actually found out that the majority of them were obese and happened to be IT, employed within IT. Maybe there are some correlations between the data we found here and the data that were found in other places. So maybe it wasn't coincidence that this group was 70% obese. Maybe it had something to do with different tests we've run on the groups. It's a very good way of spotting patterns. And finally, the last application is reducing data sizes and saving time and space. If I have a bunch of different features on the same object, but it turns out I only want to analyze a specific part of that object or a specific part of a tree I've created, there's no point looking at other parts of the tree. We can cluster each part of the tree into k groups, and we could say, oh, it turns out I only need to analyze the first group or the nth group or whatever. So it helps you save data and time and space when you're processing only specific things, a lot like pre-processing data for supervised learning. So I've talked quite a lot. Let's have a notebook break where you can go through the material and get a grasp on the data that we're trying to deal with, as well as the end goal we're working towards. I've included some worked examples. Hopefully this will give you a feel of what we're going for.